Wally needs to buy 60 watermelons for the annual watermelon eating contest. At his local discount grocery store, Wally can buy either 7 watermelons for $10 or 5 watermelons for $8. What is the least amount of money Wally can spend? We'll let X be the number of 7 packs of watermelons Wally buys, and let Y be the number of 5 packs he buys. So we have the inequality 7x plus 5y is greater than or equal to 60. We want to satisfy this inequality while minimizing the price, or 10x plus 8y. Clearly, the 7-pack is the better deal, so let's see what happens if we only buy those. We will need at least 9 of them to satisfy this inequality, which brings our total to $90. However, this buys 63 watermelons more than we have to, which means you can probably get a cheaper price. Let's try buying 8 7-packs and 1 5-pack, which gives us 61 watermelons. Our price is 8 times 10 plus 1 times 8, or $88. That's cheaper than our last price, but we're still buying 1 more watermelon than we have to. Let's try buying exactly 60 watermelons. So we need to satisfy 7x plus 5y equals 60. We need 7x to be a multiple of 5 in order to have integer solutions. Clearly, x equals 5, and hence y also equals 5. That brings our total price to $90. So by logic, the price isn't going to go lower than $88. So that is our answer. Yay. If you want to confirm this, you can list them all out, but that sounds extremely tedious, and I'm not up for that tonight. Next question. The perfect watermelon. Assume that Wally slices a perfectly spherical watermelon of radius 6 inches into 2 equal hemispheres. Then he slices each of those hemispheres in half into 2 congruent parts. By how much does the total surface area of the 4 pieces of watermelon exceed the surface area of the original unsliced watermelon? We're essentially looking for the area of all the flat parts of the quarter-sphere watermelons. As you can see, the flat parts of each of the quarter-sphere spheres are quarter circles of radius 6, as shown in the bottom left corner. The area of each of those quarter circles is 1/4 times 6 squared pi, or 9 pi. There are 4 times 3, or 12 of those, making our answer 4 times 3 times 9 pi, or 108 pi. We don't need to find the areas of the round parts because they cancel out in the subtraction, if you were wondering. The contest begins. Albert can eat 1/8 of a watermelon every y seconds. Y equals 10 plus w over 3, where w denotes the number of watermelon slices Albert has eaten so far. How long will it take Albert to eat 6 whole watermelons? Assume that a watermelon slice is 1/8 of a watermelon. We're trying to find how long it takes Albert to eat 48 watermelon slices. It is given that the time it takes Albert to eat at each slice is 10 plus w over 3. Hence, the total time to eat all slices is 48 times 10 plus 0 over 3 plus 1 over 3 plus 2 over 3 plus all the way to 47 over 3. We start at 0 over 3 because after he eats the first one, w is still 0. He hasn't eaten any yet. The sum equals 480 plus 1/3 of the quantity 47 times 48 over 2, which brings our answer to 856. We are done. Let's go to the next question. Vlad eats his watermelons over an upside-down conical bowl with radius 8 inches and height 12 inches. Assuming that 8 cubic inches of watermelon juice drips into the bowl for every watermelon that Vlad eats, after how many watermelons eaten will the height of the juice in the bowl be halfway to the top? Express your answer to the nearest whole number. We want the upside down cone to be halfway full by height. So by similarity, the volume of the juice we want is 1/8 of the volume of the cone. The volume of the cone is 1/3 of 8 squared times 12 pi, or 256 pi. Hence, Vlad will have to eat 856 pi over 8, or 32 pi, which is approximately 100.53. So our desired answer is 101, since we want to find the nearest whole number, and we are done with this question. And that is a lot of watermelons. So, thank you for watching. You should go eat more watermelons. It's summer, and thank you. If you have any questions, ask in the comments. Now, goodbye.